In this video, we'll be finding the equation of a tangent line. The problem is find the equation of the tangent line to the graph of f of x equal x squared plus 2x plus 1 when x equals negative 3. Now to find the equation of a line, I like to use the point-slope form, which is y minus y1 equals m times x minus x1, where x1, y1 is the point on the line, and m is the slope of the line. So we need to find a point, and we need to find the slope. Now we know that we want x to be negative 3, so to get our point, let's find the y value when x is negative 3. So this is y is equal to, and I'll sub negative 3 in for x into our equation, negative 3 squared plus 2 times negative 3 plus 1. So y is equal to 9 minus 6 plus 1. So y is equal to 4. So our point is negative 3, 4. And this is my x1, and this is my y1. Now I still need the slope. Now the slope of my tangent line can be found with our definition. The slope of the tangent line and we'll call that m, is the limit as delta x approaches 0 of f of x plus delta x subtract f of x divided by delta x. So we know that we cannot use direct substitution because that'll cause division by 0. So I need to find my expression and then find the limit as delta x approaches 0. So first let's find f of x plus delta x. We're going to sub in x plus delta x into our function every time we see an x. So here and here. So my f of x plus delta x is my expression x plus delta x squared plus 2 times x plus delta x plus 1. Let me put those in there. And then I'm going to simplify this before I continue working this limit. When I square this binomial, I get x squared plus 2x delta x plus delta x squared plus, and then let's distribute this 2. So 2x plus 2 delta x, and then plus 1. Now it doesn't look like anything's going to combine or cancel. So let's go ahead and do my limit problem. My slope then is the limit as delta x approaches 0 of, it's going to be a nice long numerator, this first part of my limit expression I've already multiplied out, that's right here. So I'll just copy that. And then I have to subtract from that my f of x. And f of x is x squared plus 2x plus 1. and that's all divided by delta x. Let's distribute our negative sign here. So my m is the limit as delta x approaches 0. I'll just copy this first part of it. And then distributing the negative, I get a negative x squared and a negative 2x and a negative 1. And that's all divided by delta x. Now some things should cancel. I have a negative 1 here and a positive 1, so those cancel. I have a negative 2x and a positive 2x, so those cancel. And I have a negative x squared and a positive x squared, those cancel. So my m is the limit as delta x approaches 0, 2x delta x plus delta x squared, and then plus 2 delta x, all divided by delta x. Now I can see a delta x factor in each of my terms in the numerator, so I can factor that out and cancel off this delta x in the denominator. So then what I'm finding, my m is the limit as delta x approaches 0. When I cancel this delta x with this one, I just hit 2x. And then when I cancel this delta x with one of these, I still have a delta x factor here. And then when I cancel this one with this delta x, I'll just have plus 2 in the back. Now as delta x approaches 0, this term becomes 0. So I'm getting m is equal to 2x plus 2. Now this is the expression that I can use to find the slope of my tangent line at any x value. So I want the equation of the tangent line when x equals negative 3. So I need to calculate this m at x equal negative 3 is going to be 2 times negative 3 plus 2. So negative 6 plus 2 is a negative 4. Alright, so I have my m of negative 4. I have my point is negative 3, 4. Let me copy that down here. So I can use my y minus y1 equals m times x minus x1. I'll sub in 4 for y1. My m is negative 4. And my x1 is negative 3. So subtract a negative 3. Now I just need to simplify this equation. These two minuses I can make a plus. And then let's distribute. Negative 4 times 3 is negative 12. And then let's add our 4 to both sides. So y is equal to a negative 4x minus 8. Now this is the slope-intercept form of the equation. We weren't told what form to put our answer in, so this would be perfectly fine. If you were asked for the general form of this equation, we would need to move all of our terms to one side, and since the x coefficient needs to be positive in general form, I'll move everything to the left. So when negative 4x is moved to the left, that becomes a positive 4x. And then the y is already on the left. And then when I move this negative 8 to the left, it's a positive 8. So this is the that's 0. This is the general form of this equation of the tangent line.